All right, let's get started. Welcome to the session on the good, bad, and the ugly of Java generics. My name is Venkat Subramaniam. We're going to talk about just a little bit about why we would care something about generics. Then I'll get into several examples of looking at using generics. And then as we progress, we'll talk about some of the interesting features about generics. And then we will talk a little bit about the good parts and the bad parts, and then eventually the ugly parts as well. So best time to ask a question or make a comment is when you have it. So please don't wait until the very end. Just about any time is a good time. And if you do have a question and I'm not responding to you, that simply means you're not in my line of sight. I'm definitely not ignoring you. So wave your hands or draw my attention. I'll be more than happy to yield to you and listen to what you have to say. So let's get started. We're going to talk about generics here. Generics has been around for quite a while now. We had that in Java. Those of you who came from C++ remember that we had templates in C++. And then, of course, after a while, when Java came out, Java wanted to make a simple language. And one of the ways Java became simple is by simply ignoring certain complicated features in C++. So oftentimes I would like to say Java is simpler than C++ rather than saying Java is simple. But as time went on, we realized that we do want to have collections and objects, and we want to be able to infer the type, and it becomes kind of tedious. But of course, the first question is, do we really need generics? And I have to say, I really don't think we need it. If you really, I'm usually, if I were to talk about using generics, I'm usually on the camp where I would prefer not to use it more than using it itself. And one of the reasons for that is, over the past several years, I've been programming more and more with dynamically typed languages. Now, I'm a person who programs in maybe comfortably about 8 to 10 different languages. Some of my languages include languages like Scala, which is statically typed. But having said that, I've spent enough time on dynamically typed languages and statically typed languages now that I don't depend on generic information as much as I used to. Now, it really is about our comfort level. If you're comfortable only programming in a statically typed language, this feature can help you, but if you're a person who is comfortable programming in a dynamically typed language, it really doesn't add a great amount of value to what we are doing. So one of the things I want to emphasize here is generics are not totally useless. They are useful, but let's not put too much emphasis on them and start designing very heavily with them. And in the process, let's not make things very complex. In a way, I would argue that generics have introduced a solution to a problem which to a certain extent, I would argue, does exist in a statically typed language, but for the amount of complexity that's been introduced in solving the problem, you always kind of wonder, is it worth it? And if you look at the counterpart, for example, what .NET has done, I would argue that .NET has done a fairly good job in implementing generics. And the reason is the generic implementation in .NET actually has a concept of reification, which doesn't exist in Java today, but hopefully it'll be present in Java 9 timeframe. So we'll talk a little bit about that also and what the consequences of that are as we go forward. So let's get started with some examples. Why do we care about this and what does it provide for us? I'm going to start with a fairly simple example. By the way, the examples I'm going to write here, I will post them within about, let's say, an hour after this presentation in my URL. I'll post this URL for you towards the end as well. You don't have to write this down in a hurry. I'll put this up for you later on. It's just downloads link on my website. But it's not there right now, but I'll post it within an hour or so after the talk is over. So the first question, of course, is that why do we care about it? What does it provide for us? Let's start with a simple example. We are all pretty used to this. So I want to start with the array list of numbers, let's say. This is the good old JDK 1.4 time frame, right? And Java had collections, of course, and we could use collections back at the time. And I have an array list of objects, and I'm going to say numbers.add, let's say 1. And I'm going to just start with a bunch of numbers, let's say extremely simple bunch of objects, right? Values. And then I'm going to say I have a total equals 0. I want to print this total out, so I'm going to just say total here right now. So, of course, I want to run through and do the totaling, but you can see the problem already. The compiler, of course, I'm using Java 7 here, is already giving us a warning that I have some unchecked code, unchecked types that I need to really verify. Ignore that warning just for a few minutes. So I'm going to say here, I want to total up this. So object, and we could say number in numbers. So because the array list is really, doesn't have, it's a raw type, doesn't have a generic or parametric type, I'm going to say total plus equals, and I have to say integer, and then I'm going to specify the number I'm interested in casting. And I'm sure every Java programmer here has done that in the past, and we had to do type casting along the way, and you can see that it printed the result, but the code requires type casting. Now, this is a fairly simple, in fact, trivial example, and we can see the typecasting already here, but you can imagine in a more complex situation, the compiler kind of stands in your way, and you're kind of screaming to yourself, I know what this type is, why can't you figure it out, right? It kind of becomes a little frustrating at that time, and you wish the language kind of was a little smarter. Well, actually, it is with generics to a certain extent. So rather than doing this, one of the other problems here is that numbers.add, and if I say 1.0, notice that we are not going to get a compilation error at this point. So when I run this code, you can notice that we actually are getting a runtime error, that the class not found exception error. By the way, for those folks who are standing, there are a few chairs here empty. There's no reason for them to be empty. If you want to come back here, you're most welcome to come up to the front. Don't hesitate at all. You're most welcome. This is for us, so feel free to come in and sit down. There's chairs up here. So, so the real idea here is we're getting a runtime exception. There's no reason for us to delay this to the runtime. Why can't we just, know this at compile time? Well, generics appear to be solving this problem. I'm using the word appear to, I'll say why that is a little later. So how do we go about fixing this? So what I'm going to do here is to simply say that I have a list of objects. So I'm going to say integer over here. And of course, back in here, you would probably say integer to create this object. And I'm going to remove this part for a minute. But notice the benefit of this is we can say int number, and we no longer have to do this typecasting. And we can simply specify the number itself here and run it. What a nice solution. The warning is gone. Now, if you're used to Java 1.5 or 1.6, you wrote code like this. And this was kind of a bit annoying, right? Because you had to tell integer twice because you want to make sure Java compiler really got it. Well, that's kind of annoying. You don't have to say that, fortunately, in Java 7, you can drop that part. This really becomes more comfortable when you are dealing with like a hash map, when you have multiple types, or even nested levels, you can simply put an angle. But of course, you cannot leave out the angle, by the way, because you want to say that you're really interested in the type being inferred in this case, and parametric type is used and not the raw type, so that's still important to put that little angle bracket in there. Now, looking at this code, we may say, all right, we are better off, aren't we? Well, yes and no. It is certainly better off because we did not have to type the typecasting. And what do most of us do in Java, by the way? We don't do this. We develop IDEs to do silly things we have to do, right? So we don't need to depend on the IDE. The language supports it. But unfortunately, though, this code is really not any different from the code we had a few minutes ago. It's a little, you could say it's a weak syntax sugar, if you will. It's not even a sugar, it's more like an equal that you get in the shop, right? It's not even a sugar in that regard. So the reason why it is like that is because you didn't really remove the typecasting, you just hid it. If you're not sure about this, let's take a look at this for a second. And Java P minus C I'm going to run, and I'm going to run it with the options, and I'm going to look at the sample right here that we have created. And let's take a look at what we have under the covers. I'm going to go to the main function because that's where we wrote this stuff. So let's go to main. And I'm going to look for the little famous check cast, as you can see. And therein lies the problem, as you can see right there. So the compiler is still doing the check cast under the covers. And it's then calling the int value for us. So rather than we doing this step, we relied on the compiler to do it. So in a sense, we didn't do anything different. But the real benefit is we didn't have to look at that, vomit, if you will, in our eyes. The vomit is kind of hidden under the covers, and we don't have to be doing the casting for ourselves. Not a good thing to talk about right after lunch, but sorry. So that's an example of how we didn't really remove that, but still it's happening under the covers, right? In fact, this is a little bit worse than that because even the runtime exception is not fully gone, for example. Now, we'll see how that is a little later. We'll not talk about the bad parts right now. We'll just focus on the good parts for now. We'll come back to that a little later and see. So we saw how we can use generics, and all that it gave us for right now is that little casting we didn't have to do. And again, like I said, I'm not going to completely throw that out. I think that's still a benefit because it makes our lives a bit easier when we're writing code. We don't have to be doing that casting, and certainly there's benefit to that. But then again, when we talk about generics, we can talk about generics in various levels. Let's say for a minute that I'm interested in creating a generic method instead of just using something else. So we could write, for example, a function, and I'm going to simply say output OK to say that our code is working. For most part, generics are about interfaces, right? The way to work with classes and casting them. So I won't put too much body in the code. We'll play with the interface of the methods for most part here. So I'm going to write a method called copy, let's say. And this copy is going to take a list of numbers or whatever it is from a source, and it's going to copy it into a target. We'll call it as destination, right? Or target is even better, target. So here's a function I'm going to write called target. But notice the type T. Now, you say, how does it know that this is really a parametric type? Well, we know that when programming, we should not use single letters for most of the things, right? I mean, you would agree that creating a single letter class name is an act of criminal negligence, right? Nobody should really do that, right? So you could argue that it's kind of obvious what T is. But of course, life is not that good. We do have people creating things like that. So you want to clarify what that is. So you can simply say T is the parametric type over here, and you can specify what the return type is, in this case void, or you can say T if it's going to return a type T itself. So you can see how it was easy to write that. But then of course, one of the things I want to do here is we have a parametric type, meaning we don't have a clue what we're going to receive in this case. And only requirement here is the list of type of source should be the same as the list of type of the destination. In other words, if you have dogs on one side, it should be dogs on another side. You can't put books in one and dogs in another. Fair enough. But then I want to say, I don't want to copy elements if they already exist. So I could say if target.get, and let's say for a minute, I'm going to keep this trivial. So .get, let's say, is comparable to, and I'm going to say source.get, and I'm going to say if this is not equal to 0, don't worry so much about the correctness of logic here. Like I said, I'm more interested in the interfaces of things. So all that I want to do is, for some arbitrary reason, I want to compare the two objects in this collection. Well, you see, the compiler kind of looks at this and says, huh? What does that mean, really? It bars at us and says, how do you call compare to? What does that mean, right? It doesn't have a clue because not every object in the world has a compare to method. So as a result, it says, I'm sorry, I cannot work with you on that. Well, this is where what we can go a step further is to say, hey, I'm expecting a type T, all right, but the type T is going to be extending from a comparable interface. In this case, I'm specifying what the type should really be in this case, and you can specify some of the details about it. So basically, the idea really here is compare to, right? So compare to. So let me get back to that error that I messed up a few seconds ago. So let's get back to this to say that it really is complaining. So right there, it's complaining, and I put this little comparable extends, and it's okay right now. What am I doing really here? So what I'm saying is I'm telling the compiler, all right, let's be a little bit more restrictive here. I do want this to be a generic type. I want to receive some kind of arbitrary parameters, but I really cannot be effective if I really don't control a little bit about this. I mean, the worst thing we could have done is we could have used reflection here, but that would kind of suck, isn't it? So as a result, what we said was, T extends comparable T. Now, don't take the word extends as inheritance in this context. That's really not the meaning here. What this says is that the type T derives off of either through inheritance or through interface inheritance or class inheritance. Doesn't mean that this is capable of supporting that methods that particular interface or class is going to support. So this allows the compiler to kind of do a little bit of type checking and says, all right, I will accept anything you send me that has that particular implementation. So for example, if I go back here and call the use method this time, the copy method this time, and in this case I say copy, and I want to send list 1 and list 2 over here as parameters, I mean, what can these lists be? Well, actually, let me make this a little bit easier for ourselves. Now that I've said extends, actually, let's continue with this, sorry. So I'm going to simply say integer here, for example, list 1, and I'm going to call this list integer, let's say list2, and I'm able to call these two guys here and send it, right, list1 and list2, probably, let's say, new array list. There we go. So I could send this type over here, and he's going to be fairly happy with it. Why? Because we know that integers support the comparable interface, and we should be able to send it. It bombed on us here because of this function doing some stuff, but the interface really says I'll accept it. But on the other hand, if I were to change this to a sample and a sample, which is the class in which I'm writing the code, notice that in this case he's not happy with this, and that's because our class sample doesn't implement the comparable interface, right? So it emphasizes that and checks for that also very easily. We can see that very nicely. So that's basically what we are doing here in this example, is to restrict the type information for us so we can decide what to use. So we placed constraints on generic parameters, but we can also create classes which have generics as well. So how do we go about creating classes with generics? So in this case, for example, what I would like to do is simply create a little example class. Let's call it as a list class. So I'm going to say my list is the class I want to create. But I want this to be a parametric typed class, so I'm going to specify an angle t to specify what the type is. Of course, if you want to have multiple parameters, you could say angle t comma e and give other names for these collection types, or parametric types rather. So in this case, I'm going to provide a method called add, which takes an element as a parameter. And again, I'll simply say adding over here so we can check that it's calling this. So I'm going to create a my list over here of integer, if you will. And in this case, I'm going to say list equals new my list. And we can use the angle to infer the type. And then, of course, I could simply say here, let's call the list.add in this case to run this. List.add, and I'm going to send a 1 to it. You can see that's happy with it. But if I say list.add 1.0, the compiler should again complain to us saying it cannot accept a 1.0 because the type is required to be an integer type, and you can see that it's emphasizing it. So again, creating classes seems to be fairly simple. But don't let that give you a false illusion. I'll talk a little bit later where it's not really that simple as we think it is, and I'll show you some examples where we have to be a bit more careful about this. But this leads us to something else we need to worry about. When we create classes, the next thing we get into is about inheritance with classes. So we can use inheritance in normal classes, right? You have a class base class, and you write a derived class which extends from the base class. And anywhere an object of the base class is required, you can send an object of the derived class. You say, that sounds like a great idea. How does that work with generics, and especially generics and collections? How does that translate to? There's an interesting principle called the Liskov substitution principle. It's one of my most favorite principles because Liskov substitution principle says that if you're using inheritance, we should use inheritance only when there is substitutability. In fact, using inheritance for mere code use is really a bad idea. Now, one of the reasons why we normally don't use anything else but use inheritance more often in Java is because inheritance is so easy to write in Java, right? Now, if you read good object-oriented design books, they talk about how delegation is much better than inheritance itself. Now, most of the time you would be reading this book on, yes, absolutely correct. Delegation is much better than inheritance, and you would close the book and roll your sleeves and start using inheritance. Now, the reason why we do that, unfortunately, is because we don't have a clue how to use delegation in Java, right? And if you notice how to really type it, it becomes really hard. I'll talk about delegation in one of my design patterns talk, tomorrow or day after, but we can't really do that much in Java itself, at least not yet. So what do? We normally use inheritance. Well, inheritance itself should be used only when we want real substitutability. If you only want code reuse and not substitutability, meaning you don't intend to use an object of a certain class in the place of another object of the base class, then you should not use inheritance, or we should not use inheritance. Well, let's take a look at an example of this and see how this manifests itself. Let's say I have a class called fruit. And I have a class called banana, and to keep the example very simple, which extends from fruit. And I'm also going to have a class called orange, which also extends from fruit. Now, what I would like to do is just to kind of make sure things are working the way we should use it. Let's say, for example, use fruit. And I'm going to take a fruit as a parameter. I'll call it as fruit. And we will simply print out the fruit we received here. So we'll say received, and let's go ahead and print out the fruit over here. Cool. Now, of course, I can call this method fairly easily, but to do that, let's create a banana object. And here is our banana object equals new banana. And I'm also going to create over here an orange object. So orange, and I'll say orange equals new orange. And I can call this method, right? So I can say use fruit and simply call this with a banana object and orange object. Of course, this is kind of trivial, but we want to make sure that inheritance works today, right? All right. So, but what about using a collection? Let's try that for a second. So I'm going to say public static here, and we'll call it as use fruit basket. And I'm going to take a list of fruit as a parameter. We'll call it fruits over here. I'm going to simply output received one more time, and this is going to be fruits. So what can I send to this? Obviously, I can send a collection of fruits to this particular method. Let's do something here. Let's create a collection of fruits over here. And I'm going to say basket of fruits and equals, what is this going to have in this case? I'm going to simply say equals array list of course, fruits. Now I'm going to say basket of fruits dot add, let's put the banana in that fruit basket. I'm also going to put a basket of fruits over here and add, let's say, orange to it. So notice, my fruit basket contains a collection of objects of different type, but those inheriting from the fruit itself. I'm going to send this and say use fruit basket or use fruit, what did I call it? Use fruit basket, that's what I'm calling it here. So use fruit basket, and I'm going to send the basket of fruits to it. And notice in this case, he's happy receiving it, right? Yeah, not a problem. But imagine for a minute that I go back to this code, and in the use basket of fruit, I'm going to take this fruits basket and I'm going to add a new orange to it. So I decided to receive a basket, but to add to it by putting an orange into it, right? And at this point, is there a problem? Not really, right? Because we created a basket of fruits, we send this object to this function, and when it comes back with one additional fruit. I don't think that's a problem. I can print out what I have here, and you'll see there's an orange back to you, and you're like, oh, I like this method. It gives me back some fruits, extra fruits, right? That's nice. But let's change this a little bit further now. I'm going to, instead of this, change this to basket of banana right there, and I'm going to call this as basket of banana instead of basket of fruit. And now I'm going to simply add the banana to it, nothing else. Now I'm going to call the basket, use fruit basket, but I'm not going to send a list of fruit anymore. I'm sending a list of banana. What do you think? Is it a good idea or not? No, right? In fact, if you're sending a basket of banana right now, you're going to be surprised when you get this basket back to you. You're like, whoa, how did that happen, right? This is only supposed to have, bananas in it. How did an orange come up in this? You say, Venkat, that's not a problem. We have this wonderful thing in Java called exception handling, right? I mean, we all love that so much. So within the function called, use banana, a fruit, we could check what this basket is. And if this basket cannot accept the orange, we could, after all, throw an exception. What do you think of that idea? No, you will not have friends at work if you do that, right? They're not going to really like you. One day somebody comes to your company and says, who is this guy eating there alone? And then you know why you're sitting there alone and eating, right? So such kind of interface building is not going to help build friends in companies. Why? Because it throws a surprise at you. You have established a contract in this function that you can call this function, and suddenly you're saying, I'm going to start throwing exceptions from this function, and this really makes it very difficult to use this function in our code. You don't want to go that route. All right, great. So we don't want to do that. And does the compiler help us here? How beautiful that is. It tells us don't do that, right? So error cannot, well, actually in this case, of course, the error is because of this object, but let's go ahead and change this over here to basket of banana, obviously. But when I go back, oops, I need to be consistent in changing this guy here, right? Refactoring. We need to have a tool to refactor that. So notice what it does here. It tells us method use fruit basket in class sample cannot be applied to the given type. It says, I'm expecting a list of fruit. You cannot send me a list of basket. So in other words, let me rephrase what we are seeing here. We know that banana extends from fruit, but list of banana does not extend from list of fruit. So keep that in mind, that you cannot just use a collection of derived type in place of a collection of base type. Because if we arbitrarily do that, we will get into trouble with our code. So it protects us and says, don't do that. It doesn't allow us to do that. So that's a good thing. Now, we saw how the compiler is helping us here, but I'm going to go to the quite opposite and look at a case just now. So what I'm going to do now is to twist this problem just a little bit. So let's go back to this code. Let's get rid of these functions. We don't need them anymore. And I'm going to write a function called copy. And what copy is going to do is take a list of types over here. And I'm going to make this very generic type, and let's say T over here. So this is going to be a source list. And I'm going to provide another list here. We'll call it target list. So there are two list of topics over here, list of collections over here. And we'll come back to this in a minute. How we're going to use this, we'll come back to that in a minute. So I'll leave that empty for now. So what are we going to do in this function? So I'm going to have a banana and orange on hand, and I'll have created a list of fruit for ourselves, and I'll call it basket1, and equals new array list of just the fruit itself. So let's start with that. And to this basket1, I'm going to go ahead and add over here. Let's go ahead and add a banana. We'll also add an orange to this guy. So we'll add an orange to this. So right there are orange and banana in this particular basket. Now I want to create another list. So we'll call this as basket2, if you will. And this basket2 is going to contain the copy of the data that we're going to create. So in this case, I'm going to say copy, and let's say basket1 is the source, and basket2 is the destination. And when we are done, we'll print out what's in the basket 2, how many elements are in basket 2. It better have 2 elements in this basket when we are done. Of course, I haven't implemented the code yet, so let's go ahead and implement the code. Very simple here, for, and we could say type element in the source, and we could simply say, in this case, target.add, and then the element itself. So this should give us 2 elements in the object when we are done. So we can see how simple that was, right? Great. Now let's go a little further here, and I'm going to create a basket of bananas right now, not a basket of fruit. So obviously I cannot add an orange to it, but I just added a basket of banana and added an orange to it. Then I create a basket of fruit, and now I want to say copy the bananas from the basket of bananas to the basket of fruits. What do you think? Should that be allowed or not? Well, I'm not asking will the compiler allow it or not. I'm not asking that. Do you think, I'm care more about you than the compiler. Do you think it should be allowed or not? No. Yes, absolutely. Who said no? Go play with some fruits tonight. Absolutely, right? Because you have a basket of fruits, and I give you a basket of banana, and I ask you to transfer. You would be a troublesome employee at work, I think, right? If you refuse to do that. So you take bananas from the basket of bananas and put them in the basket of fruits. What's wrong with that? I mean, that's legal, guys. That's perfectly fine, right? So absolutely. What does the compiler think? No. The compiler says, I'm going to protect you in this case, right? So when I run this code, compiler says, cannot be applied. It says, I need a list T and list T. Both of those should be exactly the same type. I will not allow you to do that. In other words, what's kicking in here? The Liskov substitution principle, right? Because it's worried that this may be a wrong operation. I'm making sense? A few minutes ago, I showed you where this is good. Now I'm turning around and saying it's not good all the time. So what you want is that override switch, saying thanks compiler, but no thanks. I know what I'm doing here, right? You want that override switch to be clicked on. Now let's consider a couple of options here. One option I can think of, and you should probably stop me when I'm thinking about it, is to say comma x and change this to a type x. I won't even try to compile it. What do you think of that idea? Terrible idea, right? Why? Because you suddenly start putting bananas into a basket of books, and that all gets squishy. It's not a good idea, right? Not something you want to do. So what do we do here? Well, you are kind of reasoning and saying, all right, let's think about this direction of copying. If I have a basket of specialized type, I can take specialized type from it, but I can put it into a basket of generalized type, the base type. But the other way around is not valid, right? In other words, you cannot take a basket of any fruit and then grab one arbitrarily and put it into a basket of banana. That's not allowed. So in other words, you need to think about the direction that you're going. Bananas are okay in a basket of fruits, but an arbitrary fruit is not okay in a basket of banana. So in order to do this, this is where you've got to kind of stare at this for a few minutes to think about it. You're saying, I'm going to accept some type where that type super T, meaning that T that you specify here appears as a super type of that type. So in other words, you're saying, I want to receive a source. Whatever that source is, I want to receive that source. And the type on the right side either is a type of that source itself, the source type itself, or it could be a type which is a base type of that type, right? So in this case, if this was a collection of fruit, this could be a collection of fruit as well. But on the other hand, if this is a collection of bananas, this could either be a collection of bananas or one of the base types, meaning a collection of fruits as well. So in this case, we said super. Remember we said extends a few minutes ago. Here we are using super in this particular case to run through this, and you can see it did copy and work just fine like a charm. Go ahead, please. No, this is possible in almost any version that supports generics. You can use that in previous versions as well. Go ahead, please.
But that's going to bring you back a basket of bananas, right?
But bring us back to where?
That'll bring you back a basket of bananas.
Yeah, oh, no. So the answer is, if you notice what we did here, we started with the basket of bananas. The left one is basket of bananas. That's the source we are copying from. And we are copying into a basket of fruit. It's a basket of fruit with only bananas, which is perfectly fine. And I can then take it and add more fruits into it later on. But it's perfectly okay for a basket of fruits to contain only bananas. But it's not okay for a basket of bananas to contain anything else. So let me put it this way. How do you say this? A basket of fruits which only contains bananas doesn't become a basket of bananas. Yeah. The return type of what? This function itself doesn't return anything. It's a void function.
Oh, you're right.
Yeah. No worries. Yep.
Shouldn't the source be super T?
All right. So the question is, could the source type be super T? And the answer is not. In fact, this is where it gets a bit tricky. That's a very good question, by the way. And this is where I said you have to sit there and stare at it for a few minutes. Because if we put the information in the wrong place, it may appear to get through the compiler, but has consequences later on. So we got to be very careful in selecting. The other question people normally ask is, should I say question extends T on the source side? Again, these are extremely tricky things. We got to reason through and figure out what makes sense. Because the goal here is not to get something that's extending from it. You want to say, I will accept a base type. In other words, you have to really clearly set the frame of reference for you and say, if this is a basket of fruit, what can I accept? If this is a basket of banana, what can I accept? You got to set a frame of reference very clearly on one thing. They're definitely really good questions, but unfortunately, you got to really reason through them, and you cannot just rely on the compiler alone to decide this. Excellent. So we talked about how we could use the wildcards and then specify the restrictions, and I think we are almost done with the good parts and the bad parts. It's downhill from now on. So we're going to talk about some of the bad parts of generics. Now, the nice thing about generics is it really makes it easier for us to write code. We don't have to deal with all these casting and all of that. But I want to emphasize, let's not put too much emphasis into generics. In other words, if you wake up one morning from bed and the first thought in your mind is, generics are cool. Call your boss and say, I'm sick today, I'm not coming to work, right? That's not a good thought to have, right? Because they are not cool, they are just solving a problem that barely exists, but it's really a complicated solution for that. So for all the complexity it introduced, as you can see, you kind of wonder how much benefit it is. Because to avoid that casting, we have built around such a complexity around it. The other thing I will also emphasize is, don't get me wrong, I'm a huge fan of compiler support. I like languages like Scala and F# in the .NET world, and Haskell, for example, that give us all those benefits. But unfortunately, we got to realize whether we are relying on the compiler doing a good job or a compiler doing a poor job of static verification, which doesn't really help us with type emphasis in a great deal, that's where it gets very tricky. So given this, let's talk about what happens to generics. Now, unfortunately, all generics go to the compiler to die. And the minute the compiler sees the generic type, it completely erases that off. Now, you may say, why do they do that? Now, I'm very sympathetic to this. I want to be fair when I say this, and I don't want to take this as an insult on the language or the compiler, but the problem with Java is the previous versions of Java, right? And the problem with Java is its success. And one of the problems with Java is they want to provide backward compatibility. Now, it is extremely hard problem to solve. If you don't provide backward compatibility, you're doomed. And if you provide backward compatibility, you're doomed. So that's really the matter of the fact. So you really have an option to know which way you want to be doomed. So I think that's not a bad thing if you can really look at it that way, right? Now, in the .NET front, they really decided to break the backward compatibility to a certain extent, and they full force went with generics, and they have done a fairly decent job. And if you look at 5-6 years later, that works really well. But this is a baggage we are carrying with Java. Now, of course, it really comes down to a very fundamental principle behind languages. And I respect that certainly, right? If Java's fundamental principle is to preserve the enterprise and not break backward compatibility, I think we should just accept that and live with the consequences of that. Because at some point we cannot have the cake and as it eat it, right? So we have to be careful about this. But having said that, let's take a look at what type erasure really means. What does it really do for us? Unfortunately, if you go back to this code, let's take a look at this example here. And for a minute, let's say I want to create a public void. Let's say static void, and I'm going to say use, and I'll say instance 1 and instance 2. So I'm just going to create this little function, and I'll just say use called. Again, remember, we are really interested in the interfaces of functions, not the implementation, so we don't have to care about what these functions do under the covers. So now I want to use this function. How would I call this function? So we could simply call use with maybe 1 and 2 here as parameters and say use called and just call this function. We got to say that this is a parametric type. We say it's a parametric type, and we saw that use was called. Now you look at this and say, all right, so what is this T really that we have here, the parametric type? What does that really mean? So let's go back here and look at the Java P and take a look at the disassembled bytecode one more time. And if you look at this line, you're going to be excited. You're going to say, look how wonderful that is. It says use T, and it says T and T, how nice that is. Well, unfortunately, the real stuff under the covers is this. So it says that this function signature is an object and an object, right? So it really kind of says, hey, let's discard the type information here. That's called type erasure. This is one thing I love about our field. We can do evil things, but give really beautiful names to it, right? And it's called a type erasure. Like, it's got to be good, right? It sounds nice. Well, it's a pretty bad thing because simply said, all the effort you put in, I'm going to throw them away. We don't care about types at this point because we cannot handle it. This is fundamentally the difference between type erasure and type reification. A type reification is where you take a generic type and you make it very concrete and say that itself is the type. And in Java, we don't have reification at the generic level. .NET has reification right now. Some of the other compilers have reification, but Java is working towards it. So eventually we'll have reification right in Java. But the point really in this case is that we are using a type erasure. But don't assume that you will always get a type object, right? It wouldn't be that simple, would it? No. You have to actually examine this a little bit to know what the type is going to be. So let's take a look at an example here further. So I go back to this example here and say, hey, but I want to say that this guy extends from comparable API. So I'm going to say comparable T over here. So now we have said that this T extends comparable T. Of course, since 1 and 2 support it, we can easily send that over there to it. I apologize for the audio here. So basically, in this case, what does this mean then? If you take a look at this now, you can notice, well, actually, is there a difference? Not yet. So in this case, I'm saying that this would be extending from comparable t. So in this particular case, it should say, I want to go ahead and change this to, there we go. So I probably didn't run the code. Let me see if that really compiled it again. Yep, there you go. So notice in this case, it said, I'm going to replace this with comparable type rather than object. So in other words, it doesn't erase it to object all the time. It simply erases it to whatever time the least common denominator it can think of at that point. And in the case of references, it's an object type, but in the case of other types, it could probably decide what the type is based on the common type. Notice also it's comparable and not comparable t at this point, so just keep that in mind as well. So, all right, that's great, but one of the things we can also do is we can specify multiple constraints as well. So you can put an ampersand and say serializable, for example, right? Or clonable, for example. And you can specify these types. Unfortunately, if you specify some of these constraints, what you would notice in this case is it serializable? One of the two that int will support, I'm not sure exactly what it supports, but anyway, whatever type you put here, unfortunately what will happen is, it'll simply ignore that again, and the erase type will be the very first thing you specify in there. In this case, the comparable is what is going to become the erase type. So to be careful about what type it's going to manifest itself. By the way, if you're not sure about what type it is, your real friend is Java P. Java P is a fantastic tool. It's a great tool to use on Friday nights when you're alone and don't know what to do, right? It gives you really good company. So open up, Java P, look at the bytecode. The streets, around you are much safer for a few hours at least as you're looking through it. So absolutely, take a look at what's under the covers and find out what the type really is, and you can kind of get a feel for it. So absolutely, when you're not sure, drill down and look at the Java P and take a look at what it contains. So type erasure, kind of, we saw the effect of that right there, but what are the consequences of doing that? Well, it really boils down to quite a few surprises. Now, of course, you really have to sit there and think about some of these things, because otherwise the surprise is even worse, because you normally learn this in odd ways, and those are not fun. So when it comes to using generic types, we have to do a little bit more deep thinking and trying things out. And we cannot just say, oh, put the type in there, parametric type in there, and it's done. So let's talk about some consequences of this. The first and foremost consequence, which kind of makes me sad a little bit, is that parametric types cannot be primitive types. And it should be kind of obvious what the reason for that is, given the type erasure problem we saw here. So for example, if I go back to the code, and I said, you know what, I just want to send a 1 and 2 after all, so why can't I just use parametric type of integer itself? So if I try something like list of, let's get rid of this guy for a second. If I say list of, int over here and list equals new array list of int, we're going to get really complained at because we cannot use primitive types in this case. It's got to be a class type in other words. So Java, as much as it's object-oriented, really is not fully object-oriented, right? Because Java still has two classes, right? The primitive types and the object types. And generics parametric types can only be object types, not the primitive types per se. So that's one big restriction we have to live with in the case of Java. The other thing is we cannot instantiate the parametric type. And for example, let's say you're creating a parametric method over here, public, let's say over here, some type, doesn't matter what it takes, and I'm going to say use, and in this, let's say we have a parametric type instance. And maybe I want another instance of this type, so I decide to call new t like this, and notice we got an error saying we cannot create an instance of that type. Now, you say, why can't I create an instance of that type? And the reason is, remember, because of type erasure, it doesn't have a clue what t really is. I mean, you would be in this wonderful assumption, you're going to create an object of banana, and you end up getting an object of object, and you're like, what good is that, right? And you kind of taste it, and it tastes really weird, and that can be very surprising, right? So you don't want that, definitely. So it kind of takes a primitive measure and says, no, I'm not going to surprise you that way. I will just not make sure you don't create it. So you say, well, wait a minute, but if I do want to create objects, am I lost completely? No, you're not. What you need to do to get around this limitation is you would have to pass a class type into this and say, use the class type as a factory to create the object. In other words, you can kind of have to use a little bit of reflection layer in there and say, send class angle t, and you say meta class, and then say, based on the meta class, create an instance, and you could use that. Go ahead, please.
Is it possible to have that specifications object that you could call constructor?
So right. So the question is, sorry?
Repeat the question.
Yes, I am. Boy, yeah, I am. What was the question now? Okay, so the question is, can I send enough information to T, like extend something? And in that process, can I do a new T? This is one thing I love about Java programmers. They have relentless hope. This is amazing. So, sorry. And the answer is, I've had similar thoughts to you. I'm not putting you down at all in this. Because a lot of times I get excited, it's like, can I do this, right? And usually it's the middle of the night, I'm screaming, I cannot do it, and it doesn't really help the children when they're around. But the point really is, no, the reason is no. Why? Because, remember one more time, if you were to specify that constraint, whatever that be, it still uses a least common denominator. And the chances are, you say, create me a banana, it ends up creating a fruit. And if that was not abstract class, you will again get an incorrect type in this case. Or who would want an object of comparable anyway? That's an interface, right? So unfortunately, while it's a wishful thinking and it's good thinking, unfortunately the mechanism wouldn't allow us to do that because we don't reach far enough to really control that. Excellent. So we saw how the type information kind of restricts us. There's another problem also we have to be careful about. For example, let's say we have a class called, let's say an interface called event. And the event is going to take some type of event and it's going to give it to us. It's an interface, right? I could have an event of string type, I could have an event of a tuple, I could have an event of something else. Who knows what the message could be in this event could be given to us. So I have a class called myClass, and this class implements the event of type, let's say, string, and that's what I want to receive in this case from this code. So if I were to go call this little code just now, let's make sure this interface is good. So we'll simply say OK for now. And when I run this, it says I'm fine. But what if I say, not only can I have an event of string, but I could also support an event of integers, for example. And notice we are in trouble right now. And the reason it says, hey, you cannot have multiple implementations of the same interface. Obviously, in Java, you wouldn't say implements, I1, I1 to implement the interface 1 twice, isn't it? So it doesn't allow you to do that. And because of type erasure, these two guys end up being the same under the covers. Now, just as a quick distinction, in .NET, there is a concept called, you can actually do interface implementation either directly, or you can also implement interfaces to say if there's a method collision, you can handle that as well. But unfortunately, Java doesn't have the concepts to handle that. And as a result, the interface implementation is pretty straightforward in Java, and you can't really push that to any further extent. So there's no real classification you can give to say, I want this to be this other implementation. You cannot specify that in this case. So you can't really control that. There is also a problem, and this is a little bit shocking because there are two problems that you wanted to solve, remember? One is to get rid of those vomits in the code, where we constantly have to do casting. To a certain extent, I would say that has been resolved. But the other problem is to avoid runtime exceptions and catch those problems at compile time. Unfortunately, that is not entirely gone. And the reason is because of backward compatibility. You could argue this is not too bad because the compiler can still warn us, but let's look at an example of this real quick. So what I want to do here, let's say for a minute that I want to pass, let's say I create an object of list over here, integer, and I say numbers equals new array list, and in this case, I'm going to simply say numbers.add1 and just deal with that. Now let's say total equals 0, back to the example I started out with, and I'm going to say int number in numbers, and I'm going to simply say total plus equals the number given to us. So this was the problem we started out in the beginning, and we said, look, it's really avoiding us to have to really do conversions, typecasting. Of course, if I had a bunch of other values here, we could use those, and certainly that makes life easier. But what if I said numbers.add 1.0? Well, the compiler immediately jumps up and says, no, you can't do that, because 1.0 is not the type I'm expecting here. So that's a good thing. But what if you had a function somewhere that was receiving an array list? This is like the old implementation that you had. And for backward compatibility, you want to call into that function. So I'm going to call a function foo. Well, in programming sessions, you have to have something called foo, otherwise the talk is not done. So I cleared that checklist. So I want to send the numbers over there to it, right? So I'm going to send that to this function foo. How would I use this function foo? So we could write this function foo here. So let's say this function foo really takes a list of numbers. We'll call it nums over here. And so I'm going to pass it to that function. So what if I call this function? We'll worry about the implementation of that a little bit later, but I'm going to go ahead and call that function and send the nums. And notice in this case, we passed it to that function, and we said go ahead and use it. It quietly kind of passed it through. Now you see this could come from another library somewhere else, and you could separately compile it. It may not be even here, right? And within this I say nums.add, and I'm going to put a 1.0 in this. And if this was an old library, old code, the warning happens on that side, and you're just calling into it. But notice what happened when you called that function. It gave us a class cast exception, a runtime exception in reality. So you could argue that you could deal with that exception, that warning. But again, the problem here is you're dealing with the old type. What can you do about it? Java does have one solution, by the way. You can go to the collections class and say collections.checked type or checked class, and then ask it to give you a particular implementation that would perform type checking for you, and you can make that a little bit more smoother, but still this is a problem we would have to deal with. But again, if you're listening to warnings properly, maybe that's not too bad. But there's another problem we have to deal with as well, and this is about unboxing that happens quite a bit. So in other words, notice what's going to happen here. Imagine we have a function, and I'm going to say get matching. And get matching takes a type T, and I'll say this is going to be a matching instance, and it's going to return to us some instance that is matching this. So in this case, T, get matching, T instance, it's going to look for this instance and see if there is something that matches this type and return if it matches. So in this case, we could say check to see if instance matches with stuff, right? And if it matches, that's great. What if it doesn't matches? If not, I'm going to say return null, right? So I'm going to return a null to say, I don't have what you're looking for, sorry, tough luck. Now, the beauty of this is you can call this with different types, but what's going to happen if I send an integer to this? So for example, let's say for a minute, let's not do this for a second, I'll return a 1 for now, and I'm going to say int, matched value equals, and I'm going to say get matching and send a 1 to this. And then when I get back this, I could say matched values, and I can print this value out that is given to me, right? Of course, in this case, what is t? Of course, this would be a type integer that I'm passing to this, right? That's what I would expect to send in this case. Let's say I'm just sending the instance itself back. How about that? Just to kind of get around it. So that was good. But on the other hand, what if it is not present? I'm going to return a null in this case, right? Now you say, what's going to happen when I return a null? Notice you won't get a compilation error in this code. When you compile this code, you will have absolutely no clue that this code is about to blow up. But if you turn up the volume of the computer, you will actually hear the Java compiler laughing right now, saying these guys thought this was a good idea to use this generic type here, right? So the point really in this case is it returns an integer, which happens to be a null in this case, and as a result, when you try to force the null into an int type, you're going to call an int value method under the covers. And when you call int value on a null type, it's going to blow up with the null pointer exception. And so as a result, you can see, in this case, it results in a null pointer exception, and the compiler wouldn't catch us for it, and we get a runtime exception at this point. So these are some of the consequences we have to be a bit careful about when it comes to using this. Please. I apologize, I couldn't hear you. Say that again.
What did
correct, but it's compounded, right? Because if I was receiving an integer type, I could do a null check, or I could use other kind of constructs. For example, I mean, you could say, don't return a null, instead return an object or a union, and then you can examine it. But the point really is, this is really more of a problem with auto unboxing than generics. But the point that generics actually doesn't deal with integer type, and you have to use the uppercase integer type, it's easy to fall into that trap. So it is not the generics is not completely guilty here. It has got other co-conspirators in this problem. So it's not to be blamed alone for sure. But unfortunately, it kind of leads you into it, and then the others kind of get you. So that's the problem. One other problem we have to deal with, unfortunately, is when you deal with a collection of objects, you have to be a bit careful about this because, I won't go into this example right now, but I'll just mention this. One of the problems you have to deal with is, take a look at collection API and the list API. Collection API says, I will remove an element which is an integer index. The list API says, I will remove an object which is given to me as a reference. And when you go try this, what will happen is, you are saying remove 3, and you're not sure if it takes 3 as an integer index, or it auto boxes 3 as an integer and removes the object. Really confusing, and most of the time it's not what you expected, and it's fun. So play with it and see how that manifests itself. And again, those things can manifest very badly. Static fields are not really a good idea in these objects. For example, let's take a look at one example here. Now, let's say for a minute that I want to create a type over here, and the type that I'm going to create here is going to be, let's say, a class called myList, and I want to know how many elements of my list exist. So I'm going to say private int, static int, and let's call it as count, or instance count. And I'm going to simply say my list is going to be the constructor, and within the constructor, I'm going to increment this count. All right. Now I'm going to write a function. We'll call it as int getCount, and this is going to simply return the count back to us. Now we all know that it's not a good idea to access a static field from my instance method. I'm aware of it. Let's ignore that for a minute. We'll come back to it. So now I'm going to say here, my list of integer, and I'm going to create a list1 equals new my list of integer. And I'm going to go ask him, how many do you have? So output list1.count, or rather get count, and it should tell us how many objects we have. It says we have 1. Now I'm going to create one more of the same type, and I'll call this list2. And of course, you would argue it should really say 2. I'll leave it on list1, by the way, and it should really say 2, which is good, right? Because those two are the same type, and it should say that we have a list2. But on the other hand, I'm now going to go back here and say my list one more time, and this is going to be of, let's say, double. And I'm going to call it list3 equals my list of double. And in this case, I'm going to ask him list3.getCount, and I'm also going to ask list1 how many elements it's got over here. Now, of course, if we really think about object and what these types are, we may naively think that there are 2 instances of myList integer and 1 instance of myList double. So we would probably say line 20 should return to us a 1, and line 21 should return to us still a 2, right? Now, when I run this code, unfortunately, you can see it says 3 and 3, right? It's kind of like a buy one, get one free offer. Where did that come from, right? Well, the reason why this messed up is these are really not separate types under the covers. Because of type erasure, we only have a myList under the covers, isn't it? So notice what's going to happen at this time. You say, you know what, Venkat, that's really not fair, because you would really not write this as instance method. You would do a static over here anyways to get to it, isn't it? So we could write this as a public static method over here and access that, right? Now, how do you get to this? Of course, you could still get it through the object, which is not a good idea. So to avoid that, you would say my list of integer dot. And finally, the compiler kind of tells you, okay, please don't do that. I will admit to you this is all kind of a trick. None of this exists. So notice you cannot call that method because, finally you hit the guilt of that object, the compiler, right? It said, I can't fool you anymore. I'll admit the truth to you. So finally you say, how do I really call this? And you drop that and you call it like this. And at that point, it becomes very clear we're dealing with just one type under the covers. And you start writing that, you would simply say my list dot, my list dot, my list dot, and it's very clear what type we are dealing with. On a similar note, there's another problem we have to deal with as well. And that problem is that when it comes to equality, we don't have different types, unfortunately. So as a result, if you take a list of integers and a list of double, and you get the class from both of them and compare it, they'll end up being equal, assuming they're in the same container. That's because they still are the same type under the covers, and they're not really different type at this point, so we got to be very careful. Now, finally, converting from generic to non-generic, something we got to be very careful. I'll give you in about 10 seconds what that care is. Suppose in this list I have, let's say this is a non-raw type we have, and you have public void add object instance, and then you also have, let's say, public void add all, which is a collection of instances, let's say instances, right? So this is let's say this is a my list itself, for example, right? So you've been asked to convert this from a generic to a non-generic type. You say, cool, I can do that, and you put an angle T over here, and then you say angle T here, and then you say angle T here, and you say, why, that was easy, isn't it? Well, one day you'll get a call from the support, and then they call you and say, your code sucks. And you will say, I know my code sucks, but tell me how today, right? And you have to kind of question this. And then you realize what they did was they created a collection of fruit, and they are trying to send a collection of banana in one case, and the code doesn't accept it. And then you realize, darn it, I shouldn't do this really. And then you realize this should really be question extends T, and that would be the correct implementation. The moral of the story is you cannot just substitute types with parametric type and go home, right? You have to write enough use examples, use cases, and try out your code and make sure your code actually works the way you like it to be. Just because the compiler compiles your code, it doesn't mean it's good. But we all know that. And yet we are so hopeful that someday that will be true. That's all I have. Thank you.